to go? Thank you for joining us for today's webinar, Building Data Apps for Dynamic System Simulations with Genie Builder. Scientific code often remains inaccessible to stakeholders due to its complexity and lack of user-friendly interfaces. However, with the power of web apps, researchers can now share their code and results in a more intuitive and interactive manner. By creating a web app in Julia, you can transform your scientific code into an engaging experience, making it easily accessible and shareable online with a simple link. Today's webinar is being presented by Genie, the #1 web framework for building data apps in Julia with little or no code. Before I introduce our presenters, I would like to cover a few housekeeping rules. We are recording the webinar and we will be able to share a link with you after the event is complete. We welcome you to revisit the content yourself and share it with colleagues. Box on your screen. If you think of a question for the speakers at any point, just type it in there and we will cover it during the Q&A session. Our main presenter is Pera Jimenez, data science advocate at Genie. Pera brings extensive experience in the development of scientific applications. During the live demo, he will walk you through the step-by-step process of building a dashboard using Genie Builder. We will also have Deep Datta, Director of Product Marketing at JuliaHub, and he will be available along with our other panel of experts like Cynthia, Daniel, and Adrian to answer some of your questions. At this time, I'm going to hand over the floor to Pera, who is going to start today's presentation. Over to you.
Thanks for the introduction, Jasmine. So let me share my screen. All right, so today I will be telling you a little more about Genie, and I will show you how to build a simulation application using Genie Builder. Now, Genie is the #1 framework for web development in the Julia ecosystem for building production-grade data applications around your Julia code. When we talk about data applications, we mean data-centric web apps that have dynamic interfaces that make it easier to explore the data that you are working with, also interact with your algorithms. Like, for instance, you can have a dashboard for browsing statistics, or a dashboard for getting predictions from an AI model, or running simulations in real time and getting the results in several of the different visualizations. Now, Genie is a complete toolbox for web development in pure Julia. And with it, you can build anything from small demos for your code to production-grade applications to APIs, etc. What we offer Genie is divided into, let's say, 2 parts. One of them is the open source stack implemented by Genie framework, where we have several packages. The main one of them is Genie.jl, which is the backbone of the Genie framework, and it implements all of the server-side code for building full-stack sites. Then on the front end, we have Steeple, which implements a low-code layer for building interactive user interfaces without having to write any HTML or JavaScript. Moreover, we have Searchlight, which is an ORM for working with relational databases without having to write SQL queries. And finally, we have first-party plugins that add enterprise-level capabilities like auto-reload, authentication, API documentation, etc. Now, built on top of this open source framework, we have our premium tool, which is Genie Builder. Genie Builder is an extension for the VS Code editor that allows you to build your web apps up to 10 times faster thanks to its visual drag-and-drop editor. With it, you can build your user interfaces visually by drag and dropping components onto the canvas in a very easy manner. Moreover, Genie Builder provides other features like the theme editor, an AI assistant to make the process even faster, and also a one-click deployment on JuliaHub. Now, Genie is used in the Julia community by many of its users, and it is also used by innovative Julia startups and also Fortune 500 companies. Here we have some of the examples from users of Genie, companies like Neuroplugs, Merck, Amazon, MB3, EvoBest, and SIG. The main thing they have in common, the main use for Genie, is that they use it for productivizing their algorithms, AI model simulations, and exposing them to the end user so that they can get revenue from these users as well. Then another use case is for developing internal analytical applications, like built on top of AI systems and other custom tools, in order to improve their decision-making processes. Now, in today's webinar, I will be showing you how to build a simulation application like this one right here. In this app, what we have is the following. We have implemented a dynamic system like the one in this diagram, which essentially is a photovoltaic panel that is charging a battery, and there is a controller in the middle that maximizes the power transfer between the panel and the battery. So we have implemented this system using the modeling toolkit, Julia library, and we have built a dashboard on top of it with Genie in order to visualize the simulation results and also control it. So for instance, we can run the simulation, change the duration of the simulation, clicking on this button, and we can explore the results here on the plots. We can also control the traces that are displayed on the plot as well. And here in this auxiliary plot, what we have is let me explain. Here on top, we have, as I said, the states, the results of the simulation. So the battery current, the battery voltage, some control signals, etc. And here at the bottom, we have the step size used by the integrator at each time step. Okay, so here what appears to be multiple lines, it's just one, only that if we zoom into it, we can see that it's just that the integrator keeps switching between values of a step size between a smaller one and a higher one. So we can see this here. This is just an auxiliary plot to show additional data about our simulation. And so let's start with the building of this application. Genie Builder will be available on JuliaHub by the end of this month. Here we can see a preview version where we can create in the projects view, you can create a new Genie project. And with this project, you can share it with your colleagues so that you can collaborate and edit the app simultaneously with them. You will be able to develop your application online in the browser with the VS Code IDE, which already comes with Genie Builder pre-installed. And once you are done with the development, you can deploy the application by just clicking one button. And then after a moment, you will have a link to access your application and share it with others. Moreover, Genie Builder is also available on the VS Code Marketplace. So if you search for it, you can already install it and run it locally. Now, once you log into JuliaHub or install the plugin locally, what you will see in your VS Code interface is the following. In the top left part of the screen, you will see your application, your Genie app, with the list of files in your application, and then a new Genie panel that shows the list of apps that is being managed by Genie Builder, along with some other properties of the app. And now let's start with the development of the application. The starting point when building a Genie app is we start with some data analysis code. In this case, it will be some code that implements a dynamic system, like the one that we have here. So we take our code that implements our dynamic system, and we place it here in the lib folder of our Genie application. Anything that we put inside of this folder will be automatically loaded by Genie and accessible from other parts of the app. So yeah, we start with this initial code, we place it in the lib folder, and here we can see that we have defined the elements in our dynamic system, like the power input, our photovoltaic panel, controllers, etc. And then we define the system of equations that connects all of these components together to give form to the circuit that we want to simulate. After that, we simply define the system as instantiate this system. And this is what we will then use in the Genie app to run the simulation. Okay, so now that we have this starting point with our scientific code that we have already written, we can proceed with the Genie app development. A Genie app is usually implemented in two files. One of them, app.jl.html, which implements the user interface. And in this case, this one, we will not be editing it manually. This is edited with the visual editor, okay? And then we have this other file called app.jl, which is the main entry point to our application. Essentially, this file, what it does is it bridges our code in this, our scientific code in the lib folder with the user interface that is implemented here. So as you can see here in this initial skeleton that we have for this file, we are doing some imports. As I said, we don't need to import our code. It's automatically imported by once we launch the Genie app, so it will be available for us to call in here. And then what we do also is load some simulation data from before so that we can show something on the plots once we first launch the application. Afterwards, we have this block delimited by the app macro, which is the one that implements the reactive code that will handle the interactivity of our application. I will explain this later, but as first sight, you can see that, well, it's not a lot of code, so it's pretty compact, and you will not have to write a lot of code to make your application interactive. So now that we have this skeleton for the app.jl file, that is the entry point, the workflow for building Genie app is as follows. We start, as I said, with the computation of our scientific code. We bring it into Genie Builder, and then we proceed with the design of the interface with the visual editor. Then we come back to this app.jl file to add the reactive code to implement the interactivity. And then we go back to the visual editor to bind this reactive code to the user interface. And after this, we are done, and we are ready to deploy the app online. So let's do just that. Let's proceed with the design of the interface. We can open the visual editor by clicking here on this eye icon. I think I already have it here open. So here we have the main view of the no-code visual editor, where we have this big square here. It is the canvas where we will be designing the interface. And here to the right, we have the... So let me make this a little bit smaller. We have the library panel where we can see the list of elements that we can use to build our interfaces. We have elements for setting the layout of the page, the text elements, also interactive components like buttons, sliders, text inputs, and even a long list of charts to pick from. There's also other panels up here, but I will explain them as I use them. So let me collapse this. And let's get started by setting the layout of the app. We start by adding a header, a 2-column row. And now we can add some components. We start with the line chart here in the first column, and also an image to display the diagram. Then we can add to the right column a header, and also a select menu to pick the states that we want to plot, a slider to set the duration of the simulation, and the button to trigger the simulation. Okay, now maybe let me set the title here to, and here we will set it to, okay. So now that we have set our basic user interface, we can maybe, we can do some styling. Okay, so to style our application, we have several options. One of them is, actually, no, let me switch back. Let me do something else first. Let me proceed with the configuration of the components now. Okay, now that we have the list of components that we need to add to our app, we can proceed to do some preliminary configuration for each one of them. We do this by selecting each component and heading over to the properties menu. And here we can see the list of, let's say, pre-specified properties, also a list of suggested properties. And if we click on this button here, we can open an even longer list of properties to pick from. For instance, for this select menu, we will add the multiple property because we want to be able to select multiple traces. And also from here, the use chips. This use chips property, what it does is it makes it so that when we add something onto this list here, we have these buttons to easily delete the element that we just added. We can proceed with the slider. Again, we can set the maximum value that will be picked from the slider to 1, maybe the step size to 0.5. There's also other fields here that option data binding. I will explain this later on after we have the reactive code. Maybe we can add markers to the slider. And for the button, again, we will set the label to simulate. And let me set this to as a placeholder. Also, let me change the icon to maybe timer. And also for the image, I already have the image and saved on my app folder, so I just need to write its path. It's a diagram SVG, and you can see it's already showing here. Okay, so now we have done a preliminary configuration of our UI, and we can do some styling. Let's say, for instance, we want to make this column a little bit thinner so that it doesn't take as much space. We can do this by heading over to the Styles panel. And in here, we have a pretty comprehensive configurator of all of the styling properties that a component can have. You can set things like dimensions, typography, and etc. And here at the top, there's also a list of CSS classes where each class applies a specific set of style changes to the application. In this case, we have these two classes that set the width of the column. So we will just remove them and replace them with the col3 class. That will set the width of this column to 3, essentially. Like the total width can be up to 12, so we just take 25% of the width of the page. Now, besides this, maybe we can make this image a little bit smaller because on the page it will be shown as very big. So we select it on the styles panel, we go to the dimensions and set this width to 60%. Okay, and also we want to center it, so we will set the margins to on the right to auto and also on the left. And let me also select its parent container and set the alignment to center. Okay, so now we have centered this element. Now, one thing about customizing the style of the application is that if you don't know what to look for, you are not familiar with CSS because not everyone is a web developer. Maybe, for instance, I'm an electrical engineer, so I'm not really that good at web development. So I don't exactly know how to configure things. So when I want to style them, maybe. In that case, to help us do our style changes, we can use the AI assistant. So let me just, for instance, we want to center this button horizontally. So I can just select the parent container, and we can ask the assistant to center horizontally, to center the button horizontally. Okay, so we hit ask AI. Now this will send a request to the LLM. In this case, we are using GPT-4. It will send a request with the code for the selected component and our query. And after a moment, we will see our changes pre-applied with a preview that we can either revert or we can keep the changes. In this case, we see that it's centered, so we will keep it. And this was a very quick and easy way to make a small style change without having to guess or know exactly what we want to change. And so now that we have this, we can preview the app, the interface right here as we are developing it. And this is our interface as we have built it. Of course, nothing works yet because, we have not added any reactive code. And let me show you one thing before I move on. We also have, when it comes to styling, there's also a theme editor that lets you set consistent styling across different applications. You can configure colors and see the preview here and set headers, fonts, sizes, etc. So it's quite comprehensive. So as I was saying, we have our UI already implemented. So we can proceed with the reactive code. What we need to have is a variable in the Julia backend for each one of the components so that it will hold the state of the component. So the list of elements we can show in this list, also something to hold the value that we pick in the slider, and something to interact with the path, right? So we do that by heading over to the app.jl file. And in here in this block delimited by the app macro, we have the reactive code. We start with the reactive variables. Now, a reactive variable is a variable that exists in both in the Julia code and also in the browser, in the front end. And this variable is, it has two-way synchronization, so that when its value changes on one end, this value is automatically updated on the other end without us having to do anything. Okay, so it's instantaneous two-way synchronization. So we start by adding the reactive variables for the state of the select menu. So we first define variable states that we initialize to a list of unknown states that we have declared earlier in this file here in our initial script. We have tagged this variable with the out macro to indicate that this value will be output to the browser from the Julia code. That is, we send this value to the browser. Then for the same component, we also define a selected state variable that will hold the list of states that we have selected in the drop-down menu. In this case, we tag it with the in macro to indicate that this will take its value from the browser. That is, when this value changes in the browser, it will be written to this variable in the Julia code. So let's proceed. Oops, sorry. Let's proceed by defining a variable to store the length of the simulation that we will bind to the slider, and also a Boolean variable to trigger the simulation. Now we have these four variables for the interactive components. What we also need is to expose the data that we want to show on the plots. So we will do just that. And first, we declare a variable to store the result of the simulation. In this case, we tag it with the private macro, since we don't necessarily need to expose this variable to the browser. We just need each user to have a copy of this variable so that not everyone is sharing the same simulation results. So we declare it here, we tag it as private, and each user that is using the application at the same time concurrently will have its own copy of their own results. After this, we define the variable that will hold the data that we will use for plotting. We just call it plot data. It will be an output variable. And yeah, we are just initializing to hold some columns. And this is a data frame. Okay, so the data that we output to the plots, in this case, is a data frame. It could also be a vector. But yeah, we are just taking some columns from the initial solution that we are loading from the disk, from drive. Besides, we also output the step size at each time step of the step size of the integrator, since we will have this in the auxiliary plot at the bottom. And then we are also outputting this variable that we will use to configure this step size plot later on, as I will show you. Okay, so now we have all of these reactive variables already defined, so we can go back to the visual editor. I will explain this code right after. This is the code for the interactivity, but now we can proceed with the bindings. And to do this, well, we just need to bind each component to a variable. So we simply select each component. And here in the properties menu, we go to the field, we click on the lining icon, and from here we can, oh, sorry, I need to save actually. I didn't save that. Yeah, you see, and now once you save the code, the list of bindings will be automatically updated, like this code is automatically reloaded. And now, once we click here on the bindings, we are automatically directed to the definition of the variable. So let's say we are somewhere else in our IDE and we can, to see this definition, we can click to be directed to the code. So now we are ready to do what I wanted to do, which is bind each component to a variable. In this case, for the options shown in the drop-down menu, we will show the states. And then for the data binding to store the selected states, we will use the selected states variable. So you can see this is a what you see, what you get is what you get editor. And it's already showing the content of the variables that we have initialized. We proceed with the slider as well by setting the binding to the t variable. And then for the button, we will just set the click event to change the value of the simulate boolean to true. Okay, so now we have set the bindings for the controls of our simulation, and I will leave the plot for the end. We can proceed now with the code that adds the interactivity. As recall that what we want to have is when we click the simulation button, we want to trigger the simulation, and also when we select a new element from the drop-down menu, we want to update the plot with new lines. So what we do is we add reactive handlers to our application. The first handler is implemented with this on button macro. It is about the handler that will be triggered when we click on the simulate button. Now this macro will watch the value of this simulate variable that is initially false, so that when it becomes true, it will run this snippet of code right here. In this code, what we do is we instantiate an ODE problem, and then we solve it. After that, we store the solution and add some extra columns to the resulting data frame, but essentially we solve the problem. And since once we are done with simulating, we also want to automatically update the plots with the new simulation. So at the end of this handler, we are reassigning the value for the selected states variable in order to trigger another handle. Okay. Now the handle for this selected states variable is defined right here with the onChange macro. Again, this macro, that the difference between this one and this one is that this one is specific for buttons. It does a little extra things, but this one is for a general macro to watch any kind of variable. So when we change the value of the selected states variable, that is when we pick a new value in the dropdown, it will run this line of code, which what it does is it picks the appropriate columns from the simulation results that we had stored here and saves them to the plot data variable. As I said, this is reactive, so anytime we update this plot data here, it will be automatically updated in the browser. So as you can see, the API for the implemented interactivity with Genie is quite simple. We just need a few macros to define our reactive variables, in, out, sometimes private, and then we just need to implement the reactive handles with the onChange and onButton macros. And with these reactive variables and handles, you can implement all sorts of interactivity. So now that we have this, we are ready to finish our application. So let's go back to the visual editor. Okay. We had already set the bindings for this component. We already have the code that will update the plots. So let's now configure the plot. We will start by configuring let me show you first the built-in chart editor that the Genie Builder provides. As I showed earlier, there's a long list of charts that you can pick from. And here there's a comprehensive chart editor that lets you switch between types of charts like a choropleth or a histogram or a long list, as you can see here. So let's put it back to a line chart, and we can configure the charts easily with this menu. Essentially, what we need to do is we have the axis for this line chart, so we just need to bind data to each axis. The data we can pick from our data frame columns. Now what we will configure is the auxiliary plot that we will have at the bottom for the states, for the step size. So we will pick for the x-axis, the timestamp. We will take it from the plot data frame. It's a T column. Okay. And then for the y-axis, we will use the step vector, which holds the step size at each time point. Okay, now we can switch it to a markers so that we actually see the points. And we can do some further customization by setting the markers to a smaller size maybe, and another color. So maybe here to 1, and the colors to black. Okay, now we have our chart for the step size. Let's edit the layout a little bit. We can remove the title and add a few properties that will help us have this plot at the bottom, like I showed you in the finish tab. So we need to add some margins configuration. Also, we want to remove the grid and then the range. And also we want to set the height of the plot. So let's configure this quickly. Let me set the margin from the left to 30 maybe to show the numbers of the axis. Also the height, I will set it to 50 and I will disable the grids. And yeah, I think I don't. Okay, let's leave it as it is. Okay, yeah. Now for the range, as you can see, it comes with a predefined value. So we will bind it to the range variable so that as you can see, when I remove it here, the range that is displayed for the plot doesn't reach until the end. We want it to take the full width. So we will just set the range to the edge range variable that we had defined earlier. This will just make it a little bit more zoomed in. And yeah, this is for this plot. Now we can proceed with the plot for the states. For this, we will use the dynamic plot component, which as you will see, we can drop it here. And now this component lets us plot an entire data frame. So as you can see in the properties menu, we have the data frame selector. So we just pick the plot data frame. We can already see some lines. Now this will plot every column in the data frame. So we need to specify which column from this data frame we want to use as the x-axis variable. In this case, we will use the t variable. And as you can see, we have every column, except for the time, already plotted in our application. And with this, I believe we have finished the application. Let's see in the preview. Yep, it's here we can see it working already. We can add things, remove them, etc. Okay, so yeah, now that we have finished the application, as you can see, the workflow with Genie Builder is quite straightforward. You bring your code in, design the interface, add the reactive code, then bind everything together, and you are done. And also you can do plenty of customization when it comes to styling, etc. Thanks to its extensive style menus. There's also this bindings panel that I didn't show, but I will show now. That allows us to see the list of reactive variables that we have declared, and we hover over it, each one of the variables, so we can see the component they are bound to. So yeah, if there's a lot of components in the page, well, it makes it easier to see where everything goes. So as you can see, this took me maybe, I don't know, 20 minutes to build, but there's also a way to start building our application even faster. We can use the AI assistant to create an initial template for our app. Okay, so I will show you quickly how to do that. Let me just delete everything that I have built for now. And maybe, okay. 1 second. All right. Okay, so yeah, it's a way to quickly start your UI design instead of having to start from zero. You can start with by asking the AI assistant to give you a starting template. Okay, sorry for this from the terminal. Okay, so I will just ask it to essentially add the elements that I added manually, like a header, a row, and the 2 columns with the controls and the chart. Okay, let's keep the changes. There might be some error here because we have not bound the variables correctly. Let me reload the UI. Well, we just need to set the data bindings for these errors to go away. Okay, but as you can see, we have bootstrap our UI quite fast. using the assistant, and now I can just fine tune by doing again the style changes to make the columns thinner or anything that that I might want to do. So yeah, I think it's in all a pretty productive workflow. So now that we are done with the implementation of the applications, we can proceed with the deployment. So as I showed earlier, we can just go to JuliaHub, and after we are done, we will click the deploy button, and after a while, well, once we click the deploy button, we can configure the machine we want to deploy on, the resources, etc. And then after a few minutes, we will have a working link to our app. And yeah, this is it for the building of the app. Let me take 2 more minutes to talk about the availability of Genie Builder. So going back to my slides. Here, regarding availability, well, right now, Genie Builder is available on the VS Code Marketplace so that you can install it locally. There's a 14-day trial for you to try it out without any time limit. And then there will also be the hosted version on JuliaHub with collaborative editing and also hosting that you will be able to try out by the end of this month, very soon. When it comes to pricing, we offer several tiers. One of them is the individual tier for individual developers. That comes with Genie Builder and also community support. We offer a heavily discounted price at $250 per year. Then there's also the Teams tier that also has on top of the individual tier direct support from us and also dedicated onboarding sessions. There's also a 10% discount for yearly licenses. And then for enterprises that might have more specific needs or a large number of users, we also offer the enterprise tier. In this case, it has a custom price depending on the necessities. And what we have on top of the support, and also we offer training, we also are available to tailor Genie Builder to the needs of your enterprise. Yeah, any component that you might need or any extra features, we will be able to implement them for you. And finally, yeah, here I have some QR codes with links to download Genie Builder. Also, you want to have an onboarding session for free with us, where we can introduce Genie Builder to you in a more personalized manner. And also, you can meet our sales team for a meeting to talk about bringing Genie Builder to your company. And with this, I'm done with this demonstration. Thank you all for listening and for being here. If there's any question, I will be more than happy to answer it.
Thank you, Pera. If anyone has any questions, please post them in the Q&A chat box. I have a few questions already, but if you have any pending questions, then please post them. So Pera, the first question is, how customizable are the user interfaces created with Genie Builder?
Well, sorry, I don't know, I opened a Zoom window. Okay, now. So how customizable is it? Well, you have full control, like it's a web application, so you have full control from the interface. You can customize it with styling, okay? Any CSS property for any component that you might want to change. As I said, we also have the theme editor. In the future, we will also be supporting custom components, okay, with custom integrations. As I said, if your company requires any custom integrations, we are able to implement them as well. So yeah, as it is, it's built on top of web technologies. Anything that can work in the web, and I think you can integrate with Genie Builder as well.
Okay. We have a question. Does it support the default GR plot library?
No. The plots are implemented with Plotly.js. So any plot that we have here in this list is implemented with Plotly. You can also use, well, if you are using another plotting library, you will have to look for custom ways to bring your data as a vector, and then you can bring it into Genie Builder. But as of now, it's all plotly.
Okay.
But
We have one more.
we can also add custom based. I mean, we can also implement a custom visualization, as I said. So any other custom library like charts.js or so can be definitely added.
Okay. Is it possible to add a chatbot to my data app with Genie?
Is it possible? Well, actually, it is. It is. We have a user, Jan. He's building an interface with Genie for his package. If you are familiar with it, it's promptingtools.jl. And he has an open repository where he's building a chatbot with Genie. So it's definitely possible. Now, about integrating a chatbot with every Genie app that you are building, that's something that would require more work. So it is not possible from the get-go, but you can definitely build chatbots with Genie. And we have users in the community that are already building that.
Okay. How does Genie Builder handle scalability for large-scale simulations and data sets?
Okay, well, when it comes to the simulation, of course, this is Julia code. So, well, the code is running on your computer or on a server. So, yeah, it depends on the intensity of the simulation. On the part that concerns Genie Builder, that is the visualization or the data that is displayed on the plots, I think it can handle up to quite a lot of data. Maybe, let's say, in this application that I have here. In this case, these points here, I believe they have maybe 25,000 data points, the entries per line. So yeah, that's a feasible data set, and we can make the simulation longer. But I think it's can go quite far. There's also GPU rendering for the visualization. So here in the plot, you can pick the GL type of plots, with essentially will render the plot using the GPU. So that's even faster. Okay, so yeah, I think as far as I said, we're using Plotly, and Plotly has these GPU rendering capabilities. So I think it can go quite far.
Are there any security considerations to keep in mind while deploying the app?
Can you repeat again?
Yeah. Are there any security considerations to keep in mind when deploying a Genie app?
Now, well, of course, as with anything you deploy online, you have to keep in mind security. If you deploy on your own infrastructure, you can deploy with a Docker image, which is one of the ways we recommend, and you will have to handle the security in that case. Now, when you deploy on JuliaHub, it is equipped with features like, well, it has HTTPS already enabled for you. You can also set control access so that you can have password access or limited access to your application. But in terms of security, yeah, I think it's just a matter of from your infrastructure point of view, limiting the access however you see fit to whatever talks to the Genie application.
Okay. We have one more question. Can you please provide a comparison between the free Genie framework and Genie Builder?
Okay, so the free Genie framework is essentially you do everything with code. So what is the same between the two is the writing of this creative code, both in the free framework and in the builder. You have to write this, but then when it comes to the user interface code, in the using Genie framework, the stipple package, you write the user interface code, the user interface using Julia. Okay, so you just we have equivalent calls to HTML elements that will generate the UI, but you write that using Julia. For Genie Builder, you bypass the writing of the UI code, and you just do that with the with the visual editor, which is I might say in my case for me it's a much faster and much more pleasant experience than having to deal with code, because well, you can place things right where you want them. Also, we have all of these configuration options and the AI assistant as well that might help you do things even faster. So you have the option to use the full framework, but with Genie Builder, you can accelerate your development speed quite a bit.
Okay, I think that covers all our questions. Meanwhile, Cynthia and Adrian, do you have anything to add to what Pera has already mentioned?
Yes, actually, Pera, would you mind going back to the slide on pricing? I just wanted to expand.
Just a minute. I just have one more question. Can I start the free trial in 1 month, or is it only temporary now?
Well, I don't know. Adrian, maybe you can answer that, but I think you can start it anytime you want. It will be 2 weeks trial anytime.
Yeah, we can start the extension right now and go ahead and use it.
Sorry, it was hard to hear you, Adrian, but basically the free trial starts from the moment you sign up, Henrik. Yeah. So 14 days. I wanted to add also that because there might be students or professors in the audience, we are offering a free educational license. There's a form on our website. And actually, Jasmine, I can share the link to the form with you for a follow-up email. And fill in the form to apply for the educational license, and we'll be in touch with you. Going back to the pricing slide, I just wanted to expand essentially, when we look at the monthly price, for individual users, it's 50 per month, but obviously we recommend the annual price. It's heavily discounted. We offer that because we know there are a lot of researchers and individual champions of Julia in industry that need something accessible to popularize their Julia work. So that's really like, I think, a very compelling offer. Then if you're using Julia in your company, if you're a small team, essentially the price is $100 per user per month with a minimum of 3 users. And if you opt for the annual license, we provide a 10% discount. And like Pera suggested, for enterprises, of course, we would provide a custom quote, as we understand enterprises might need custom integrations and have specific requirements to tackle. I hope that clarifies. So overall, we're talking about a very accessible tool that can speed up your Julia web app development significantly. In our tests, we have a blog post on our website where we compare local tools and local tools like Genie Builder. We estimate that Genie Builder can speed up your app development by up to 10 times versus the status quo of actually coding your application backend and front end. Are there any other questions on availability, pricing? Feel free to reach out, of course.
And I will be following up with an email which has all the resources that will help you get started. Yeah, yes. Someone raised a hand. Okay, so if we don't have any further questions, I think thank you everyone for joining us today. And we look forward to you starting your Genie Builder journey soon. Thank you, Pera and Cynthia and Adrian.
Thank you, everyone.
Thank you, everyone.
Thanks.
Thank you, Jasmine. Take care.